Hello everyone, welcome back to the channel. Today we are solving Leetcode 78 subsets. Now this particular problem is a very standard and a very good problem for you to practice. Why? Because of two reasons. One, it is a foundational concept. So what does a sorry, what does a foundational concept actually mean? It means that if you are able to solve this problem and if you are able to deeply understand how this problem is being solved, it's going to help you solve a lot of other problems as well. So what I'm really saying is, my professor used to say that there are many thousands of problems in the world, right? And we're not talking about problems which are just in the set of DSA. We're talking about random, we're talking about general problems right now, okay? But then every problem is somehow a variation of, it's derived from a root set. If you are able to understand the root problems very well, so it makes it easier for you to solve the other thousands of problems as well, right? Now I'm not revealing the topic right now. Okay, what exactly is the topic that we are going to use, the concept which we are going to use this problem, but we are going to sort of find through it, find discover the solution intuitively, right? We are going to build our thought process and then ultimately stumble upon how the problem is actually being solved, right? So the problem statement says you're given an integer array nums of unique elements. So you have unique elements. Return all possible subsets, which can also be called as the power set. The solution set must not contain duplicate subsets, and we can return the solution in any order. So we have unique elements, and what we need to do is we need to return each and every possible subset, or you can also say subsequence. Okay, if I use the word subsequence over here, then that can be regarded as correct as well. Now something that you should know is that there is a difference between what a subsequence is and what a sub array is. So when I'm talking about a subsequence, I'm talking about, for example, if I say 1 comma 3. Now 1 comma 3 is a subsequence of nums. Why? Because I chose to take 1. I did not choose to take 2, and I chose to take 3, right? So this is a subsequence. So you take some elements, you do not take some elements, right? So you take some elements and you do not take some elements. You can say you choose to skip or ignore some other elements, right? But then when you're talking about a sub array, you are talking about a contiguous part of an array, right? So for example, it could either be 1 2, or it could be 2 3, but it cannot be 1 3, right? 1 3 is not a valid subarray, it's a subsequence. Now what we need to do is, given an array nums, we need to return all the possible subsequences that can be derived from it, right? So let's see how we can do that. The example that is given to us is this one, okay, 1 2 and 3. Now I mentioned a very 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 important point in front of you when we are talking about subsequences, and that is that our approach, our strategy is to take some amount of elements and skip some amount of elements, right? So keep this in mind, because this is literally the gist of things. This is the only thing which you need to know. So what I'm saying is, I am going to start from an empty array and I'm going to make a decision about one. I'm going to say, okay, do I need to take one or should I skip it? I'm going to try both the situations, take and skip. So if I take the one, I end up with one, and if I skip it, I have an empty array. Now since we have already dealt with one, we are now going to talk about two. So again, I have two choices. Should I take two? Okay, let's take two. Or should I not take two, right? Similarly, should I take two or should I not take two, right? Should I skip two? Perfect. Now I'm talking about the last index that I have. So should I take it? Okay, let's take it. I take it, I do not take it, right? Take and skip on repeat. That's it. That's the simple formula, right? And skip. Similarly, take and skip. Take and skip. So you see, if you count the number of subsequences that we are able to make, 1 2 3 4 5 6 7 and 8, which makes total sense. Why? Because you have 3 elements and 2 to the power 3 is actually 8, right? Remember this, whenever you have n elements, and if you want to generate all the subsequences from those n elements, it's going to take 2 to the power n. As you can very clearly see as well, it's not something that you need to remember, it's something that you can very easily understand. Now this particular tree that I have made, you can sort of extract from this that since I have made a tree diagram in front of you, maybe we are talking about recursion. And you are 100% right, we are in fact talking about recursion, right? So what we just saw right now was that how can we actually generate all these subsequences from an architectural point of view, from a bird's eye point of view, right? But then now we are going to talk about how we can actually implement it in our coding environment, right? So let me choose to let me not choose to let me open the diagram over here, this one, and let's code it up over here. So what we need to do is basically return all the possible subsets, all the possible subsequences, and we need to return it as a vector of int. So I'm going to make one and label it as answer, right? And I'm going to have a function. Inside of that function, or maybe let's do one thing, I'm going to make a vector which is current. Now what is current basically? Let me tell you. current is nothing Current is nothing but this thing, or this thing, or maybe this thing, the intermediate parts. So how in each and every step, even these, right, even these, how what I'm doing is I am sort of temporarily creating these arrays, and then I'm using them in the next call and then the next call. So I need a vector of int in order to be able to do so, right? So what I'm going to do is I am going to create a solve function. I'm going to pass inside of it the index which I'm currently at right now, but I'm obviously at index 0, and now I have a choice whether to take index 0 or whether to skip it. I'm going to pass current and I'm also going to pass answer, right? Perfect. Now I need to create the solve function. I'm going to first of all int I, then current. So current is a vector of int and percent current, and then vector of vector int, what do I have, and percent answer. And it's very important to pass the answer to the array by reference, because if you do not do so, you won't have the ultimate answer back in the main function, right? Perfect. So yeah, I have two choices that I need to do, right? I have to either take the current element or skip the current element, right? So in the take case, what I'm going to do is this. So in the take case, I'm going to say, okay, current dot push underscore back. I include the current element. I also need to pass, as a matter of fact, nums, right? Because obviously I need to be able to access the elements over here. So vector of int and percent nums. When I'm including the current element, I'm going to say, okay, sure, push back nums of I inside current, right? This is exactly the same replica of what I did over here, right? And then I have all of this space to explore. Current dot pushback nums, okay, and then I'm going to make the recursive call. I'm going to say, okay, now move on to the next index. Current remains as it is, answer remains as it is, and nums remains as it is as well. But then at the same time, I'm also making this particular recursive call, isn't it? Wherein I choose to skip it. So skipping basically looks something like this. Since I have already pushed the current, one inside of my array. Right now my array contains one. I need to remove it, isn't it? So what I'm just simply going to do is I'm going to say, okay, current dot pop back, right? So you remove the current element and you further explore I plus 1 current answer and nums. As simple as that. You don't need to do anything else. That is it. Now the base case is very important, right? So when you reach index out of bounds, so when I is equals to nums dot size, when it reaches nums dot size, that's your base case. Right now your I is out of bounds, you don't have any valid index right now. So what you need to do basically is, you are at this point, or at this point, or at any of these points, you need to push these vectors inside your answer, inside your 2D vector, right? So I'm just simply going to do, what I'm going to do is say answer dot push back whatever the current state of current vector is. whatever the state of current vector is, and simply return from here, right? Now at the end my answer is populated and I just need to return the answer from here. If I do that, let's see if it passes the example test cases. It very clearly does. And if I submit this particular code, you can very clearly see that nums.length is 10, and it's going to be accepted. Now why is it accepted? Even though, if you think about it, just like I said, it's 2 to the power n time complexity. The time complexity for this particular code is 2 to the power n, and the space complexity is also, if you think about it, it's we are taking so much extra space in the form of this recursive tree. But then why it's being passed is because nums.length is actually very small, and 2 to the power 10 is within our acceptable limits, right? So yes, now since now you know how to understand all the possible subsequences, so the next thing that we are going to do is we are going to solve Leetcode 300, and we are going to see how this particular concept helps us over there. I hope you found the video helpful. This was a very good basic template of recursion. So if you know the take and skip logic, you'll be able to solve many thousands and thousands of problems which are related to recursion. So I hope you found the video helpful, and I will see you in the next one.